a YouTube video showcasing an impressive diabetic prediction model developed using Google Colab and Python libraries such as Pandas NumPy. Uh, this is a widespread health concern that affecting millions worldwide, and early detection plays a vital role in managing the condition effectively. So, by analyzing crucial factors like patient's age, glucose level, skin thickness, BMI, and diabetes predictive function, a model can assess the likelihood of diabetes development through the power of ML and data analysis. So, we demonstrate how this Google Colab empowers us with free cloud-based resources to train and evaluate the model seamlessly. So, let's get started. So this is our Google Colab environment where we have created a Jupyter notebook named Diabetic Prediction Model. So first we will be importing all the libraries which will help us to train our model. So as you can see here, so we are importing a Python library, that is NumPy and Pandas. Also we will be using Scikit-learn, that is SKLearn, to import some important functions like standard scalar train test with SVM, accuracy score. Also after importing all the important libraries, we will start collecting our data. So that is data collection. So inside the data collection, here we have created a dataset variable which is storing the CSV file, which contains the record of patients, their age, their glucose level, their blood pressure, the skin thickness, insulin, BMI, that the diabetic pedigree function, then the final outcome. So which is 0 that represents that the patient is a non-diabetic, and that 1 representing a patient is diabetic one. So after data collection, we are on the step of data preparation, that includes data separation, standardization, and scaling data, spreading. So we separate our data in x and y variable. So which x is an input variable and y is a output variable. So the standardization and scaling is done on these variables. So here we are splitting the data. So once we split our data in 4 variables, that is x underscore train, is x underscore test, y underscore train, y underscore test. So we train and split the data. So the test size here we are representing as 0.2, which means that 20% of the data we are going to use for testing. Now it's time to train our model by using a linear support vector machine. So we are training our model with the help of that SVM. So to check if our model is accurate or not, we will find the accuracy of our extreme and the X test. As here you can see the accuracy of our extreme data is 81%. So which is a good one. Then the test prediction. So the accuracy is 77.21%. So after training our model and finding the accuracy, now it's time to test our model. So the data here we are using is for a non-diabetic patient. So the input data is 42, 120, 82, 47, and 159, and 36, and 0.251. So here 42 is the age of the patient, and 120 is the glucose level, and 82 is the blood pressure, and 47 is the skin thickness, and 159 that denotes the insulin level, and 36 represents the BMI, and 0.251 that representing the diabetes pedigree function. So we have to proceed with this. So we can see the patient is non-diabetic now. So now check this model with the data of a diabetic patient. So we are providing another new input data with 35, 186, 84, 42, 89, 35, and 0.286. So that representing the data of the patient who is having a diabetic one. So now we are checking the model. So after providing the data, now we can see the result is the patient is having diabetic. So now we can understand the diabetic prediction using this support vector machine. Thanks for watching the video. I hope you understand the concept of how this diabetic can be predicted with the help of this model. Thank you.